Hello, everybody. This is Dr. Bucknight coming at you again for your second energy section here. So I hope you guys are doing okay. And in this section, we're going to talk a little bit about a little bit about energy. And you got to remember the first law of thermodynamics in the second law of thermodynamics. So the first law of thermodynamics is we can't create or destroy matter, and the second law of thermodynamics basically means every time you use energy, you need a little bit more energy to keep it going. Just like you need to eat food every single day, you need the 3 squares a day to keep on moving, right? And then the same thing was with any energy. Your car needs gasoline once you go a couple miles, right? So harvesting energy requires the use of heavy machinery and construction roads and all this stuff to get that to the gas station for you to put in your car so you can have some locomotion. And the equation for that is the net energy equation, which is expressed by the difference of energy returned minus the energy invested. So all the oil and natural gas and human labor that we put into getting that oil out, all right, and that barrel of oil, um, return on that barrel of oil. So all that energy, now we can use that oil and do the labor of 40 years of manual labor, all right? Or we can go so many miles, okay? So all the energy we got to get that oil out and how long we can use it basically and what we use it for. Same thing with a solar panel. All right, the net energy going into all the stuff, the mining to get the solar panels out, and then how long can that produce electricity for us? Or the wind turbine, all the steel for the wind turbine, and how much electricity comes out from that wind turbine. Okay, and now as an ecological economist, I add in the carbon impact, all right, the loss of biodiversity in that, any pollution. Okay, so I add in those little externalities, not just the energy put in. Okay, but this is a common equation that you're going to see when equating what we should do later on in life. Okay, and it's known as the EROI, energy returned, and then we get the what's called the energy, the ERI, the energy returned divided by the energy invested. Okay, so the energy sources are assessed using the energy return on investment, which is calculated by the energy return divided by the energy invested. So this ratio rises when the extraction becomes easier or more efficient and decreases when the resources become depleted and harder to extract. All right, so our net energy decreases as it becomes harder for these things to extract. Way back when, the United States, when we got our oil and natural gas, for every 1 unit of energy put in, we would get 24 units out. Okay. In recent years, it's one energy unit put in, you get 11 out. You got to remember, you got to do your proper equation here and look at the same kind of energy units, whether that's calories or BTUs or what have you. Okay, just make sure you do your math, and you can see the energy return on investment for discovery has greatly gone down. All right, so we're not getting as much energy out as we put in for discovering. We used to we just put a straw down there and we got a whole bunch out. All right, now it takes a little bit more. And for production, it's basically stayed the same. All right, and technology has actually brought it down. The fracking industry did some stuff, but that some of that technology is getting a little bit. Law of diminishing returns is happening in some of that technology, but it's still a good thing. It's a little bit less. All right. So where will we turn for energy? So there are enormous amounts of energy, money, and technology are being used to extend our reach for fossil fuels. So we're a very affluent nation. So we have a lot of money and technology to implement. And the oil and gas wells are being drilled deeper and in places that were once unreachable. So the Arctic seabeds are a hotbed for investment and for companies trying to get to the Arctic since it's global warming. Now the sea ice isn't there; it's a little bit easier, but they still got storms, and that's what they've been finding out. Also, Russia and some of the Norwegian countries are going up into the Arctic area. Okay, but we also have what's called the oil sands, which are being tapped into, and that's mostly found in Canada and up in the tundra. We talked about that when we were doing the biomes. Tundra is one of the one biome that's not really affected that much in society. We haven't really replanted there, but we're scraping it on up to get that tar sands out. And it's estimated that we've scraped up about the size of Florida already up there in Canada. Okay, and there are some tar sands also in the United States, but we basically frack. All right. So how did this fossil fuels actually get here? Fossil fuels were formed 100 millions of years ago, and they are basically plants. All right, primary producers, those magical plants that have taken that sunlight, that hydrogen and helium molecule, compressed it in the center of the sun, bounced around a whole bunch of times in the sun, and it came out 100,000 years later, and a plant grabbed it and turned it into carbon. And that plant eventually died and got covered up and turned into coal. All right, a piece of algae turned into oil. So you got the algae biodegrading down here, and you get your oil deposits. Okay, it's basically all just old plant matter. And the difference why it's not renewable is because it takes millions of years to form. It gets compressed and moved around, and kind of like a nice little milkshake in the bottom of our for the oil. Or the coal is basically just layers of old wood that never got burned up, and now it's just easy for us to scrape it up and burn it all, right? Because coal is just basically a hard rock, but it's actually woody organic matter compressed and dense down to its carbon structure. So it's like that fine milkshake. Over the years, it got compressed and moved around in the earth and made into that fine coal. All right, and some of it's right on the surface where we can do some what's called strip mining. Some is down underneath where we do make little tunnels. All right, and sometimes we just say, we don't need to do anything. We just blow up the top of the mountain, right, and scrape off that layer of coal. And then when it's all done, we flatten it out and plant it, put some trees there, or make a RDC park, or a shopping mall or something like that after we're all done. But we can't put that mountain back. And this is happening in West Virginia, in the Appalachian Mountain Range primarily. Okay. Crude oil is unrefined oil extracted from the ground, basically all old algae. So it's the lipid oils of the algae we have in there from millions of years ago. And we can actually make it currently with new algae, and we'll learn a little bit about that from renewable energies. But basically, it is just old algae. Natural gas comes from methane that was released by bacteria, anaerobic bacteria, a bacteria that works without oxygen, and just collected underneath the ground for us to be able to release. Okay, and then we have petroleum, which usually refers to oil, but also refers to oil and other natural gases collected. So crude oil is that sweet bubbling crude that Jeb shot at the ground for the Beverly Hillbillies. Petroleum is a whole bunch of different things. So when we looked at that one, the peak oil for the United States, where our crude oil little chart that showed our production, right? I always say that crude oil did hit peak way back in the 70s. We just put petroleum, which had a different carbon chain in it, because the fracking and the shale oil, and the tar sands are two different things. They're called bitumen and I can't remember what the other one's called, but they're actually three different carbon chains. So we ran out of the carbon chain of crude oil, and we just have what's called now an economic substitute, which is something different. And they need their own little bell curve for the peak as well. All right. But I am probably in the minority of that thinking. All right. Um, Oil and natural gas are derived from marine plankton, like I said, just from the old bacteria that was down there, and algae and bacteria. Um, and there's a whole bunch of different areas where we get that formation. Unconventional fossil fuels are not yet used too widely. The oil sands and the fracking are not that used that much. Basically, only here in the United States. Russia does have the ability to do it, but they have not expanded into that area as of yet. Due to sanctions, actually, that we have on them, they can't get that technology imported into their country. So they can't basically do that tar sands and some of the fracking that they want to do to expand their uh, oil exports. Okay, and that's part of the reason why some of this oil price is going crazy is the Soviet or the Russia wanting to expand get more of the market share. Okay, and they might just increase their production and drive prices down even further. Who knows what's going to happen? So we also got the oil sands, like I said, and you can just see we just kind of scrape off the top, get down to the bitumen part, what it's called, okay? And we scrape that up, and then we take it up to a refinery and refine it on out and put it into the down the Keystone Pipeline. If you guys ever heard of that, where they had the I stayed with Standing Rock. That was all part of the Keystone Pipeline. And this is all basically done in Canada. We do have some places in the United States that have this, but not as much as Canada. This is their primary production. Okay. But what we do most of the time is we do the fracking. All right. So we can also have oil trapped down underneath here. All right. And down in Texas and in Colorado and some of the other areas, we do a lot of this fracking. Instead of getting the natural gas out, we're getting the oil out of there. All right. So this is our primary, and that's what that one J curve on the production scale is all from. It's all done from this fracking when oil hit $110 a barrel. Fracking industry went crazy. Then the price plunged, almost got back up to half, and the price plunged again. Okay, back down to the $20 a barrel, and I don't know how long the fracking industry is going to be able to last. And we might even just bail them out. I have no idea. We've still got to get any of that money. First, Congress got to pass it first, so we'll see what happens. So that's the oil shale. That's where we do most of the fracking, right? And then the methane hydrates are the same thing. It's the same kind of fracking. Oh no, excuse me. And then the natural gas is the same kind of fracking almost, just a little bit different. So forget natural gas. Methane hydrates are solids consisting of molecules that are like crystallized in the water off the sediment of the Arctic Ocean and ocean floors. And we can actually mine that stuff and bring it up and burn it just like we can coal. Right? And it's like frozen natural gas basically. And that works really good, but it's very expensive to go get it because it's underneath in some very hard places. And also it is a greenhouse gas, all right? And when we release that, it's 4 times methane. This is 4 times greater than greenhouse gas. And one of the tipping points we talk about in climate change and global warming is if it gets hot enough, the Arctic is going to warm up and already release these methane hydrates into the atmosphere, causing that positive feedback loop for it to get warmer faster than it would before, because these have been frozen, taken out of the methane cycle, just like the carbon cycle, for millions of years and placed inside the ocean. Okay, and if we release that to the methane cycle, and we over exaggerate the methane that's in the atmosphere, changing the temperature of the earth. Okay, so economics determine how much we will extract. how much will be extracted. Okay, so portions of the fuel are physically accessible are called technologically recovered. So we had the technology to frack, we had the technology to stick that straw in there and suck it out like a little milkshake. All right, we had technology with the pick and axe and shovel to go get to that coal. Right, so those are the ones that are technically recoverable. Some is never will be technically recoverable, and we know it's there. Some might be technically recoverable if it becomes more profitable, right? But we'll never really run out of oil, folks. There will always be some there, and when we actually kind of need it for a lot of some products, because it's found in just about everything we have. All right, so oil's never really going to go away. We just got to use it wisely. Okay. The economically recoverable portion of the fuels depends on the cost of extraction. Make sure that we could actually make some money. And right now, that the fracking industry here in the United States is not going to make any money at $23 a barrel. There ain't no way. So that price is going to have to come up, or we'll put a big tariff on the imports, causing their price to go up and make it more economically feasible. That's what a tariff basically can be used for. So we'll see what happens in the oil market in the upcoming months. Then there's proven recoverable reserves. So this is different than the physically recoverable reserves. This is everything, all right, that are both technically recoverable and economically recoverable. All right, so we've got to be able to get it and actually use it. All right, so on that one status, when we actually saw the proven reserves and it came out to 11.8 years or something like that, that is what we were looking at. So that was the reserves, both the fracking and the stick the straw on the ground, or the deep sea wells, okay, off the coast and everything like that. All the stuff that we can actually get and actually sell are the proven recoverables. So you can see that this table shows the amount of produced and consumed. All right, and you can see that China's production of coal. All right, they produce a lot of the coal, 46% of the coal, and they are also the percent of the world's consumption. All right, United States, we produce 10, right, but we only use 9.6. All right, Australia, they produce 8, and they're not even on the production. Most of that stuff is actually sent over to China out there. Okay, and Japan doesn't even produce any because they don't have that, but they still use 3.2. All right, now, Japan might have some, but I don't think so. I've never really seen them on a list. Okay, and see, the Soviet Union or Russia doesn't have any production, all right, or not in the top 5, but they are still a consumption of 2.3. Okay, now oil is something different. All right, this is the production of I think this is oil. Oh yeah, oil. Okay, production of oil. United States, 13.4%. We produce that much. Okay, with all that fracking and everything like that. So we really are a big producer in the United States. We tie Saudi Arabia. I don't know how much longer this is going to last. Okay, due to the marketplace as it is, and then Russia is at 12.2. So the 3 big ones are in a like a price war going on right now. Saudi Arabia is the only revenue they have, and this funds their government. They're losing billions of dollars a day. Right? Russia, same thing, funds their government. United States, we're lucky. We have more of a diversified economy. Most of our economy is based on consumerism and service industry. The fossil fuel industry, oil production, is just a small fraction, but it's still maybe even 5, 6, 7, 8%. It's still a good portion of our economy. Don't get me wrong. All right, now Iran, same thing in Iraq. These guys are all stuck. All right, we're the only one with really a diversified economy, and some of them are changing. Okay, but look at the world's consumption. We produce 13% and we consume 20%. All right, so like I said before, we are 5% of the world's population, but consume almost a quarter of all the resources, and we are 20% of the resources of the oil out there. Unbelievable, 5% of the population. China has 1 billion more people, and they're only 12% of the population. I mean, we almost double their consumption. Unbelievable. Okay, and then India 4%. And now all these consumption things are just going to drop um, dramatically in the next quarter. Right? Who knows where our consumption is going to be because of this virus? I'm definitely not driving that much, even though I still got a lot of electric on me. Okay. Um, and you see here, I also want to note this right here that this comes from the BP, British Petroleum Statistical Review. So we went over the EIA website. This is another good place to get a lot of data about the world's energy. Okay. Economics. Okay. And then also let's look at the natural gas. The United States, a big producer of the natural gas. We are a frack. We frack away. We do produce a lot of the natural gas. And then we're also a big consumer, 22% of the world's natural gas. 5% of the population, 22% of the world's uh, natural gas. Right? Soviet or Russia, a big fracker too. Okay, 16%. All right. Qatar and Iran do have a lot more natural gas than they do actually produce. All right, but they're just not able. Qatar and I would say Iran more has a little bit more. Okay, they can produce a little bit more if they could get the technology out there. Okay, so we're finding the fuels is the key. All right, so when we look at the different fossil fuels that we get out, there's all different grades. You get different grades of oil, different grades of coal, different grades of natural gas, and they need to be cleaned up before we actually get them out. And we try to make sure that we use every little last drop of them. And each one's a little different grade. So that fine crude oil is a lot nicer than the tar sands because that tar sand is kind of like a thick, viscous kind of, it's like a rock. It's like that tar it's like asphalt. And we just get that oil off the asphalt and then put it into our cars. So, and it doesn't flow that good and stuff like that. All right. So each one has a different price and a different quality. All right. When it comes to crude oil, we just basically boil it down. And we get a couple different things. We get that butane for our lighters. We get and naphthalene for our lighters. Then we make some of the gasoline. We got kerosene, diesel, lubricating oils, fuel. All right, and then the residue we actually can even use on our roads and stuff like that. All right, so we use about every single ounce of that fuel from the oil. Okay. A lot of it, though, 49% of it goes into the gasoline that we put into our engines and drive around on our cars. Okay. Uh, the other another 24% goes into the diesel fuel and heating oil. Right? Heating oil is just a lot less than the diesel. So I would probably say that's only about 4%. All right. But the diesel fuel is used in our tractors or in our cars. A lot of Europe uses the diesel. All right. Jet fuel and liquefied petroleum for other gases. So it's a higher grade for our higher like machinery for our jets and other things that need a lot of power. And then the other is just the residuals, right? And this is where we make some of our plastics and a whole bunch of different products out of. Right? The amount of products that we get out of oil, I think everything you touch just about has oil in it. Right? Just remember all of our roads. That's basically some of this leftover blah stuff at the bottom. Right? But each fossil fuel has its own mix of uses. Okay, coal is primarily used for electricity. However, right, that is like its primary number one use. But we do use it. We used to use it for like a locomotion for the cars, but that just got a little bit too far for the railroads and stuff like that. It's got a little bit too much. All right, but now basically we just take it, we burn it, boil water to make some steam that turns a turbine that has some copper wires going around a magnet and gives us that electricity. All right. So coal's primary function. All right. So if I ever asked you to name me a non-renewable energy and what it is used for, you would say coal is non-renewable, and we primarily use that for electricity. And all we actually do is just take that coal, put it in here, we create what's called a slurry, or we pulverize it, depending on what kind of grade it is and stuff. And we just basically burn it. and we start this fire, and the water in here, this is some water, boils up, makes some steam, and that steam goes through like a little hose and gets stronger and stronger and stronger, and that steam turns this turbine. And inside of this turbine turns this generator, and inside of this generator are copper wires. It's a magnets, and you probably did this in 8th grade science or maybe 9th. And it goes around and you make electricity, and it sends that electricity to go light a light bulb. Okay, and as long as this fire is going and this turbine is spinning this generator, we're getting the electricity. And then the water is cooled, right, and either released back into the stream or whatever, or it is back into the system. All right, so the cooling tower is basically what you're seeing is that white smoke is basically just steam cooling off from the water. Okay, and then there's some other smokestacks that are usually kept out of the distance. All right, and then we also have the ending ash. All right, and this coal ash has become a big old problem. All right, so as an ecological economist, I would look at, not just the energy it took to get this coal out of the ground, and then the energy that we got out of it via electricity. I would look at how this coal ash is handled, all right, and then all the environmental damage done for mining that coal, the mountaintop removal, all right. Now those birds aren't there. What happened to the biodiversity, right? All for a fire. Now, oil is just about in everything, or natural gas and petroleum are just about in everything you use. I mean, yes, we use natural gas for electricity. We're trying to use that more, and for heating and cooling. But most of your plastics are actually, and petroleum products are from natural gas. That plant, there's actually what's called a cracker plant being built in Aliquippa, just in the Beaver. I mean, it's this huge plant that is going to take the natural gas from this area and turn it into plastic pellets so that we could make more plastic out of it. And we'll never get rid of plastic either, folks. We've got to use it a little bit more wisely. But plastic has some very important uses as long as, we just got to use it smartly. Right? There's a lot of medical supplies that use plastics. There is, even a TV and stuff. So if we use it wisely, it's all right. We just, got to stop throwing in the ocean as much. Okay. So we are depleting our fossil fuel reserves like no tomorrow. I think we saw this, in that first video of exponential growth, how we are dwindling through our fossil fuels, and we see that even our oil already is a little bit on the teetering side. All right. So analysts calculate the reserves to production ratio, and that's what basically we did with our U.S. Right. We took our reserves, proven reserves, we divided by our production. We came up with 11.8 years left of oil here. All right. For oil reserves for the year, it's 51 years, and this, I think we saw was 40 years, 48 years, or something on world meters. All right, we'll have to double check what that number is. All right, so we can see that oil. I really do get concerned with the world supply only being 51 years. What's going to happen? But that's going to decrease, or that's going to increase, because right now we're not using much oil, right? I mean, the whole world is basically shut down because of this coronavirus, right? So that number is definitely going to be changing. Who knows where this will go? I think it's a perfect opportunity to start living a little bit of I don't want to say slower, but more content. I don't know. If we can still live good without driving as much, maybe we should just consider doing it. But it's never here nor there. All right. Natural gas reserves. All right. To last about 53 more years. Coal ratio 153 years. Okay. So there's each fossil fuel has a different lifespan. Okay. But the actual amount of years left over, like I said, could change due to different things, different atmospheres, but eventually extraction of a non-renewable resource will hit its called peak. All right, it's peak oil, peak of everything. All right. If demand holds steady or increases, when this happens, shortages and price increases or price volatility are going to happen as well. And this scenario is called peak oil. All right, with petroleum. There's going to be a peak coal, and there's going to be a peak natural gas. There's a peak everything. All right, but it was first estimated with oil by Hubbard's peak a long time ago, and we saw this on the EIA website. Right, this exact same graph, and this was the United States peak of oil. All right, and then it came back up and went back down, and then we added the fracking into this. All right, and that's how we actually overcame this peak and had this new slope. But if we didn't have this fracking, it would just closely monitor this little bell curve. We would hit maximum production right on top, all right, and then what's called terminal decline of production. All right, and this came true with unconventional, or with conventional oil, but other than unconventional oil has kept us going. All right. Uh, so a lot of people say, is the world going to reach its peak at some time? Some people say peak oil has already happened. And I am one of those believers that peak oil has already happened. That's one of the reasons why we have all this price volatility. But that is just me. You can make up your own mind. But someday peak oil will definitely happen. It's a law of physics. The more we take out, right, the our ability to increase that production stops at some point in time. All right, so it definitely will happen. It's just a point in time. It's no end of the world. All right, it's not we're out of oil or anything like that. It's a point in time where our production of a certain fossil fuel reaches maximum production and then is in terminal decline. All right, so we get up to the top, and then all of a sudden we can't produce any more oil. All right, no matter how hard we try, no matter how many more wells we put in, we'll never get to the peak of our production. All right, and I think we're already there. Some people say it's going to happen in a couple years. With this coronavirus, we'll see definitely a decline and an increase, and then probably a decline again. Who knows what's going to happen with this virus? Okay. So why don't we stop here and then we'll talk about reaching further for fossil fuels and coping with the impacts. All right. We'll talk a little bit about mountaintop removal and some other good old stuff. All right. So I'm going to go ahead and try to post this to YouTube and help everybody stay safe. And you got any questions, give me a holler. All right. Thanks.